Good morning, I'm Jinan. Here I'm to present the week 4 project, surface area integrals and flex. The figure I have taken is an umbrella. It is made of 3 figures, the hemisphere, the cylinder and the cone. The first figure is the hemisphere and my parameterization of the hemisphere is this, and I have taken two surfaces, the curved surface and the circular surface. And for the curved surface, I have found the area Jacobian here by taking the determinant of the cross product of dou x by dou theta and dou x by dou phi. In this, theta and phi are the variables. And I have given the value, I have got the value r square sine phi plus phi by 2, and I have given the value in the MATLAB code. As in the value I get as r square sine phi, I have added phi plus phi by 2, as my limit is from minus pi by 2 to plus pi by 2. As for drawing the figures, MATLAB consider it to start from the vertical direction to make it horizontal direction. I given minus pi by 2, but in case of finding area, I have to take from 0 to pi. So I have given it from, I have added a pi by 2. And in case of surface 2, the ring, I have got the area Jacobian, Jacobian as r, and I given here as r in the MATLAB code. And for getting the normal of for the circular surface, I know that the normal is in the downward direction, the minus E3 direction. So I given x1 as 0, x2 as 0, and x3 as minus 1. And for the hemisphere, I know that the normal is radiating outside, like normal to the surface. So I have divided the area Jacobian with the cross product value, and I got that as minus cos theta sine phi, minus sin theta sine phi, and minus cos phi. And I have manually calculate the value, and I got the area of the surface 1 as 402.12 and surface 2 as 199.29. And for the figure 2 cylinder, my parameters is r cos theta, sin theta, and z. There is only one surface which has a variable of theta and z, and the surface is the curved surface of the cylinder. So I have got the area Jacobian as R1, as I'm taking the determinant of the cross product, in which R1 is a constant. So I'm taking R1 into 1s of size t. And I got the normal by dividing the area Jacobian with the cross producted value, which is the normal will be radiating outside of the in horizontal way of the cylinder, which is cos theta, x1 as cos theta, x2 as sin theta, and in the case of there is no radiation in the third direction, so x3 as 0. And I have found the area by manually calculating the area. I have calculated the area, and I got the area as 37.7 by integrating the area Jacobian with the limits. And my third figure is the cone, in which the parameterization of the cone is given. I have taken one surface, the curved surface of the cone, and I have cross-producted the parameter by the variables d theta and dz, and I got the cross-producted values, and I took the data determine. I got the area Jacobian as this, and I divided the area Jacobian with the cross-producted value, and I am getting the normal as h1 by r3 square plus h1 square into cos t minus hy square root of r3 square plus h1 square sin t, and this one. And the area Jacobian which I got here is given as the area Jacobian here for the calculation of the surface area. And I have integrated the value manually. I have integrated the area Jacobian which I got here, and I've given the MATLAB code, and I got the value is 5.40. And so the total surface area of my umbrella is 644.51, which is same as the result given by the MATLAB code. And the flex, the value of the flex, and the total volume of the body is also calculated by the MATLAB code. This is the scalar field I have got, and I have given x1 square plus x2 square as to get the maximum value in the tips. As I have said in the last presentation, that for an umbrella to hit by a stone, the maximum force will be on the end point, so that I given at this point. So guys, thank you.